Okay, I am back. Sorry for that. Okay, I'm going to sharing my screen, recording. Okay, let's get back to what we were talking about, which was question 4. All right, so as I was saying, we're trying to calculate the length of the green arrow. That's your margin width. Now, the equation for that is 2 over the norm of W. Right, so I'll explain what that is. All right, now this is the size of the green arrow. This is what you're trying to work out. And I'll just call it M. You can call it whatever you want. I'm just going to use M because I need to assign it to some variable. All right. Now W is what's given to you. That's your normal vector. W is the normal vector. Okay. And now my example, what I'm going to do is I'm going to use my own normal vector. All right, so here, let's say it's given by 4 and minus 3. Okay, so this is its x coordinate and this is its y coordinate, right? So to work out the norm of W, which is the denominator, all right, we use this formula, and it's given as the square root of x squared plus y squared. All right, so we know our x, there is, and there's our y. So if you plug that into it, you'll get an answer of 5 for this example. So now you know what this is. You can feed this back into this equation, which was essentially used to work out M. And remember what M is? That's the size of the green arrow, which is what you want, the margin width. Okay. Yeah, you can suggest converting it to a decimal, your final answer. Yeah, that's my advice. Okay. So that's essentially what the margin width is. Yeah, yeah. All right, now the spelling of the diagram is wrong. All right, but that's not important right now. That's question 4. Let's move on to question 5. All right, question 5. Compute the mean and standard deviation, then give the standardized values, the z-scores, and interpret what they mean. All right, so standardizing variables. So let's get back to use my Excel. All right, and I'll talk you through pretty much what we're trying to do here. Okay. And just erase everything. All right, great. So for question 5, 1 second. What you're trying to do is you're trying to standardize variables, right? So if you're given a corresponding x value, all right, you want to convert it to a z variable, right? And then how you do that, okay? The equation that relates these two is this. It's z equals x minus mu all over sigma, all right? So in order for you to convert your x to a z-score, you would need mu and you would need sigma. So what is mu? Mu is just the average of all your data points. Okay? And sigma is the standard deviation, specifically the population standard deviation. Population standard deviation. All right? So to work out the average, well, you need a bunch of data points to work out the average. So let's say I created some dummy data here. These are my x values, okay? Column B, these are all my x values. So to work out the mean, you add them all up and divide by how many numbers there are. In my case, I have 10. I have 10 numbers, so I'm going to add everything up. So now I can equal sum, add them all up, all right? And then you can divide by how many there are, 10. Or you can use Excel function average, all right? But check what I've done here, all right? It's easier, it's up to you. So that's my mu. So in this case, my mu is 55.9, all right? So the formula for mu is sum of all your x's over the number of data points that you have. Now sigma, that equation is a bit different. So before you get sigma, you actually need to find sigma squared. It's easier to find sigma squared, or you can just go straight to sigma, right? But I'm going to show you sigma squared first. So sigma squared, the equation for that is sum each x value minus the mean squared all over n, all right? Now, what that means is you take each x value. So let's look at the first x value here, which is 15. There's my mean. Okay, so x minus this value, which is what I'm doing here, right, in brackets, and then I square it. I raise it to the power 2. I do the same thing for the next one. All right, that's my x value minus the mean. So that's why fix your mean. Okay, you can see my there's dollar signs for my mean value, so it doesn't change. I'm always subtracting the mean for each x value as I go down, and I'm squaring the result. Right, remember to use brackets here. Right, so I do this for everything. Once I do this for everything, then essentially the numerator in my equation is just the sum of this column. That's that's essentially what I'm doing here. That's the numerator. Okay, so this what I've circled here, that's my numerator. And then all I need to do is divide by how many data points there are. Remember, in my example here, n is 10 because I have 10 data points in my example. So if I just take that, I divide that by 10, that'll give me my variance. Yeah. And then once you got your variance, sigma squared, if you want sigma, you just take the square root of sigma squared. And that gives you your sigma. That's your standard deviation. Yeah. You just take the square root of that. All right. Now, once I've got my sigma, okay, I've got my mu, then I can start using this equation. So if I want the equivalent z value for my first x value, so if you look at here, my first x value is 15. So when x is 15, the corresponding z value is, I'm going to use this equation here that I've got in a block. It's going to be x value, which is 15, minus the mean, which is 55.9, all over your sigma, right? Which is, yeah, 24.6. Let's make it 24.7. All right, and whatever value I get here, and I have that, it's here. It's minus 1.65. All right, so let's make it minus 1.66, minus 1.66. That's my first z value. I would have to do this for all my x values, okay? So I'll do it for the next row, which is 71, all right, here. Then I'll do the same thing for 46, all the way to the last value. You've got to do it for all of them. Each of them will have a corresponding z value. And what does this value mean, all right? So because it's a minus, right, what it's saying is that this value for 15, when x is 15, it means it's below the mean, or it's on the left of mean. And by how much? Well, that's what the number actually tells you. The number tells you it's 1.66 standard deviations to the left, or you could say below the mean, of the mean. And if it's a positive value, then it's on the right of the mean. Okay, so it's above the mean. That's essentially what your z values tell you. Okay, so that's your what is that, question 5. Question 5. Yeah, question 5. All right, question 6. All right, the radial basis function kernel. Now, I'm not going to show you the RBF kernel because it's giving you the answer. But I'm going to show you for a different kernel. The principle still applies, and I'll explain what exactly the kernel actually is, right? I know you haven't covered SVMs yet. So let me clear my board. All right. Let's get to my 6. Okay. 1 second. All right. So kernels are essentially it's just a way to calculate a similarity between 2 points, right? So let's say I had 2 points, and I'll write one point as being x and another point as x prime, right? So x is 1 point and x prime is another point. So kernels measure the similarity between these 2 points, right? Similarity. Now you get different types of kernels, right? The example I'm showing you now, I'm going to use a polynomial kernel of degree 2. But the principle applies for the Gaussian kernel. It's just a different function, but how you apply it is the same, right? Now, for the kernel that I'm going to use, like I said, it's a polynomial kernel of degree 2. So in other words, we write it mathematically like this. And don't be intimidated by this. It's just me showing you the notation, right? But once I show you how to apply it, it's actually not difficult. So you will always be given the kernel, right? You'll be told what kernel to use, and it's very easy to just look up what the functional form of the kernel is. So in our case, in this example, we're using a polynomial kernel. So I'll explain the notation in a second. All right, plus 1 squared. So this is where, when I say a polynomial kernel of degree 2, that's where the 2 comes in, all right? In your assignment, you're asked to use a Gaussian kernel. So your equation here for star is different. But all it does is it measures the similarity between 2 points. And I'll explain to you why that's important, all right? But for now, let's just try and figure out how to actually calculate the similarity. So to do it, let's give ourselves 2 points to actually walk through this example. So let's let x for the first point, let's give it some values. It's in a 2D coordinate system. So it means, you got your x and your y. So it'll have an x coordinate, it'll have a y coordinate. All right. And then x prime is the other point. And let's make that 1 and minus 1. Okay. Right. Just gonna make sure I'm sharing the same screen. I think I am. Wait a minute. Okay, that should be fine. Okay. All right, so back to my example. All right, so we got the 2 points. These are the coordinates for it. Now, we're going to use the kernel to work out the similarity, all right, for these 2 points. So I'm going to apply this kernel to these 2 points. So how I use this equation. So let me just take you to this part where I'm underlining first. So here you'll see xt, which is x transpose times x prime. Now x transpose just means that if you have something written like this, then if you transpose it, you actually write it, you transfer the columns to rows. So you had 2 columns before in the top, now it becomes 2 rows in the bottom, right? And where you had 1 row on the top, it now becomes 1 column, right? So basically your rows and columns become switched around. But essentially what you're trying to do here, right? So if I have my 2 points here, so x, my x here is 2 and 1, and my x prime is this, 1 and minus 1. All right, so what you're doing is something called a dot product. A dot product, all it is you take the first value here, so your x's, you multiply them, right? So it's 2 times 1, okay? Because those are my x's. Then you take your y's, yeah, which is your 1 times 1, 1 times minus 1, times minus 1, and then you add them up. That's what a dot product is, okay? So that's what you're doing here, okay? So you multiply that out, okay, and you'll get 1. Now remember, I only did this part, but I'm underlining. There's still a plus 1 part here. Okay, so I still need to do that. So if I want the full value for my kernel, it's going to be kx x prime, which is the underlined part here, which we did already, which is 1, plus the 1 here, and I raise it to the power 2, and that gives me 4. Right, and that tells me the similarity between them. Now, why is that important? Well, that is important because for SVM, right? So I'm just gonna share another diagram for you. If you recall, second, let me get to my documents, 1 second. I want to share a diagram with you to kind of illustrate what I'm talking about. Okay. So here, what you'll see on the left, okay, you'll see these orange dots, and I'm using the orange just to say that's one class. Okay, so those are the people that bought the product, and then the blue dots are the ones that didn't buy the product. Now, if you recall earlier when we were talking about SVM, SVM aims to create margins, these red lines, okay, that separates these 2 classes. And what the kernel is useful here in SVM. So if you have a new point that comes along, say this new point, it has an x value of 2.5, and it sits at, let's say here. So this new point is here. I'll make an x there. So this new point has a coordinate of x value of 2.5 and a y value of 10. Now, what the kernel is used for here is you have these points on the one margin for the orange dots, right? These are what we call support vectors. So what the kernel does is it works the distance out between this new point and that support vector, and then this new point to that support vector. You get the distance from that. So this distance, I'm just going to mark it as 1. We use the kernel to calculate that, just like how we just did it a few moments ago. It used the same way to get the distance or the similarity between this orange point and this new point. So now you're working out the similarity between these 2 points. So you've got these two, similarity 1 here, similarity 1 here, and you've got similarity 2 here, right? Now those are for the orange dots. So what you would do is you would get an average of 1 and 2. So let's say the average of 1 and 2, let's say the value is, I'm making this number up, okay? Let's say it's 3.4, right? For the orange dots. Right. Then you would do the same thing for this new point and the support vectors for the other class here and here. So you would get the distance here. Let's call this distance 3, and we'll call this distance here 4, using the kernel to get the similarity. Okay, and then you would get the average for these two. What is the average for that? And let's say the average for 3 and 4 is 4.8 for the blue dots. So because based on the similarity, that's what determines which what you call this class it goes to. All right, so that's what the kernel is used. Sorry, I should have actually mixed these values up. I should change it. This should be 4.8 maybe, and what do you call it, 3.4? But it doesn't matter. What's the takeaway here is your kernel calculates a similarity. That similarity is used to determine which class this new point will become. All right, whether it'll become a blue dot or whether it'll become an orange dot. All right, that's how the kernel fits in, and it will be covered. But for the purpose of the assignment, all you need to know is how to use the kernel. All right. Now I showed you how to use a polynomial kernel. You will have to use, I think, a RBF kernel. So you get different kernels. There's even, I think, the tanh kernel as well. But with the assignment, you're being tested on the Gaussian kernel. So the equation is in the assignment. You just need to apply the equation for the 2 points. Okay, let's move on to the last question. All right, here you're using, you need to answer the question on k-means clustering. Okay, so for k-means clustering, all right, now I will take you through my example on k-means clustering in this Excel. Okay, so we are asked to do this for 2 iterations. Excuse me. So how I've laid this out is I use the centers that's given to me, right? So each, what do you call this? Centroid has a center. You're given 2 centroids. So my first centroid has an x value of 1.5, and my second centroid, my y value for my first centroid is 2. So in other words, let me just erase this. New notes. All right, so you're given centroid 1, and it has coordinates 1.5 and 2. All right, and then my other centroid, centroid 2, has coordinates 2.5 and 3.5. Okay, so that's shown here. All right, so that's my second centroid. It has an x and y value, and my first centroid has a x and y value. So what you're doing now, essentially for k-means clustering, okay, let me try and use a better drawing of a shape than I could do freehand. All right, I think that's good enough. All right, so you got all these points. I'll mark them with an X. And let's say centroid 1 is here, right? This is its coordinates, which is given by here. So what you're essentially doing is you're looking at every point, and you're going to get the distance to that centroid. All right, so maybe this is my first point. This is my second point. I'm going to get the distance from that to that centroid. And that's what I'm going to be doing here, right? In this column here. This is my first point. It has an x and y value. Point number 1. Point number 2 has that x and y. And I'm getting what I'm showing here in the diagram, this arrow, this line with the arrow, that's given by n. That's the size of the arrow, the line of the arrow, the distance. So to get that distance, right, we would use the distance formula. So the distance formula is square root, right, your point x1, I'll explain what the x1 and x2 is right now, minus, I'm going to put c1 here, all right, all squared plus y1 minus yc1 all squared. All right, so basically here, this arrow that I'm darkening, I'm going to use this formula to work it out. All right, so my x1 is the x coordinate for my first point, which is this 1.1. And my y1 value is its corresponding 0.9 value. Now the xc1 is what is the x coordinate for centroid 1, and that's 1.5, right? And what is the y coordinate for centroid 1? That is 2. So I would substitute these values into this equation, work it out, and that's what's my column n. All right, you need to write this equation on Excel, but essentially what you're doing is this equation here. All right, then for the next point, you do the same thing, but instead you're going to be talking about x2, the second point. But your centroid 1 doesn't change because you're getting the distance from the second point to that centroid. And you do that for all the points, the third point, the fourth point, etc. 2. Okay, so this will be for your second point, and you so on and so on until your last point. So that's what I've done here. All right, so that's my distances for every point to centroid 1. Now you need to repeat this process for centroid 2 because you have 2 centroids. So now, when you're doing it for centroid 2, you're just going to replace these values here with centroid 2 x values. So C2, YC2, C2, and C2 here. All right, so you'll be dealing with this value for XC2 and this value for YC2. So in other words, now you have to work at the points, the distance to centroid 2, and using the same formula here for each point. All right, and that's what I have in my column O. I'm doing that for each point. Right, you need to write that formula out. Yeah, so you've got the distance for each point to each centroid, and then remember, if you have a point that's closer to centroid 1, that means the distance is shorter than the distance to centroid 2, then it would belong to centroid 1 because it's closer to that center. Right, so that's what's happening here. Now, I prefer to use an if statement to it. You can do it manually if you want, but by looking at it by eye. But I'm just saying, if my n1, the value in n1 is smaller than the value in O, then make it C1, otherwise make it C2. All right, it's up to you. And I'm dragging that formula down for everything, and you can see that 4 points in my example belong to centroid 2, and 2 points belong to centroid 1. Now that is just one iteration, and please, when you answer this, specify which iteration you're doing, right? So this whole process that we did, we just did it for one iteration, right? So that's why I put a note there, iteration 1. Now I'm going to repeat this process, but the only difference now is that my centers are changed. Okay, centroid 1 has different coordinates now based on what happened in iteration 1, and the same applies for centroid 2. Okay, now if you look at how many points fall under centroid 1, there's 2 points. So my new centroid 1 would have a new x coordinates, and that would be the average between these two x values because there's only these 2 points that belong to C1. So in other words, my new, sorry, all right, so you can see here, I use an average if statement. So what I'm saying is, if column P is C1, then average X, otherwise don't average it. That's the way I like to use it in Excel, but you don't have to do it. You can do it manually if you want, right? I use the average if formula to do it, okay? So in other words, my new C2 coordinates all right, is going to be, right, all the x values that fall on C1, so which are these, it's going to be averaging these two, so this plus that divided by 2, right, or average of these two, right? So that's why my new coordinate now is 1.175. And the same applies for the y coordinate. C1 will also have a y coordinate. And here it's the same thing. I'm just doing my average if, but I'm averaging the y values now, okay? So if it's C1, then take the y into account and I'm averaging. Otherwise, don't take into account. Okay? All right, so those are my new coordinates for, oh, why am I doing my C2? This is C1, sorry. This is my new C1, 1.75, 1.135. I do the same thing for my new C2. Okay, now you'll see for C2, there's a lot more values, a lot more points that fall under C2. There's 4 of them. So the new x coordinate is going to be the average of all these x values. Right, you average those, and that's your new C2 center. Okay, and in this case, it's 3.65. 25. And then the same thing applies to the corresponding y values. All right, so you got your new centers, okay, and you repeat the process. But now you repeat the exact same process you did for iteration 1. But now remember, when you're calculating the distance, all right, your distance is now based on the distance to C2. As you can see now, it's referring to the new C1 coordinates. And the same applies for my new, the distance to C2. I'm going to use the new coordinates for C2. All right. And everything else still applies. All right. So it's basically a copy and paste of iteration 1, but remember to change your center coordinates for iteration 2 based on these. All right. So here I'll run the same formula to say, okay, if the distance to C1 is smaller, make it C1 out of C2. Now, if you look at the values in column P for my first iteration, it's C1, C1, and then the rest are C2. And if you look at it for iteration 2, it's exactly the same. So what that means is that the points didn't change. They remain in the same classes as iteration 1. And that is what convergence is, right? When there's no change in which cluster points go to, then that is what you mean by convergence, all right? Okay, so this is how you can use Excel to do it. You can put iteration 1 and iteration 2 below each other. If you want to put it here, if you want to put iteration 2 here on the right, you can do it. It's really up to you. But please specify which iteration it belongs to, okay? We won't know when we're marking. So if you don't tell us, then it's showing us that you don't really know which is the iteration, okay? It's not just a matter of just trying to follow formulas. You need to try to understand what you're doing when you're putting this together. All right, that's question 7. I believe that's the last one. Yeah. Okay. Yeah, that's it for me, everyone. I hope this helps. Yeah, this is going to be probably posted as 2 videos because I had to stop in the middle of the first one. All right, but I'll make both available. All right, all the best. And yeah, if there's any questions, please feel free to email me.